Today we're going to be talking about section 1.7, and 1.7 is on solving absolute value equations and inequalities. So an absolute value, the absolute value of a number x, represented by the symbol with the two vertical lines and then the x in between it, is the distance between a number is from 0 and on the number line. So we're always talking about a distance. Absolute value is always a distance. How far is something from something else? So if we look at example, or interpreting the absolute value, it says the absolute value of x. Well, that's how far is x from 0? Well, the meaning is that's the distance from x to 0. So if we put 0 on our number line, and we are going to go so many units, we know that this is the distance that that number is from 0. And so since they tell us that it equals k, we know that we're going to a point k here, and we're going to go the same distance negative the other way, and that's going to be negative k. So these distances are both going to end up being k units. So that's what the absolute value of x equals k. So the same thing is going to be true here. We have x minus b, the absolute value of that, equals k. Also, what we're going to say is that we're going to put our point B here, because that's where we're starting from, and we're going to go k units this way and k units this way. So the distance between them is the same. So this would be the point B plus k, and this would be the point B minus k. So when we write this, it's going to be x minus b equals negative k, because we went k units to the left, or x minus b is going to equal k, because we went k units to the right. So when we solve this, it'd be x equals b minus k, or x equals b plus k. So that's kind of what that one means. And then in this side, it's going to be x minus 0 would equal negative k, or x minus 0 would equal k, which means x would equal negative k, or x equals k. So that's what the graph looks like, the solutions look like. If that doesn't make a lot of sense, let's look at example 1. This should make sense. We know that the absolute value is a distance. Well, that distance in this example here is going to be equal to 15. So I know I'm either going 15 forward or I'm going 15 backward. So what I'm going to do is I'm going to write two inequalities for this. I know that the distance from 2x minus 9 has to equal 15. Okay, we have to go 15. That is what it says. Or I know that we could go the other direction. So 2x minus 9 would equal negative 15. So anytime you're solving an absolute value equation, that's what we're doing. We are setting up two equations. We're solving them. So 15 and 9 is 24. So x equals 12. Or we're going to add 9. We get negative 6. So x equals negative 3. So when you have an absolute value, you're going to have two solutions most of the time. So let's plug those in. We should plug them in to check to make sure that they work. So if we take our negative 12, or sorry, 12. 12 times 2 is 24. 24 minus 9 is 15. The absolute value of 15 is 15. 15 equals 15. We got it. Now we're going to check the other one. Negative 3. 2 times negative 3 is negative 6. Negative 6 minus 9 is negative 15. The absolute value of negative 15 is 15. And so we'll have 15 on the left side and 15 on the right side. So that is the solution as well. So both those two are the solutions to this problem. And then once again, if we would graph these, we need to go to, we'll go by threes. And so when we're looking at this, we know that -3 is one of our solutions. And we know that 12 is another solution. So there is the graph of our solutions. Notice these are just 2 points now. So those 2 points are the solutions. All right. If we want to break this down in step by step on solving an absolute value equation, here's what you need to do. Step 1, we're going to write 2 equations. Set it equal to it and set it equal to its negative counterpoint. Then solve it, then check to see that the solution works. So example 2, same thing. We're going to go 4x plus 12 equals 28, or 4x plus 12 equals -28. Okay, because we again know the absolute value is a distance, so it either has to be 28 or it has to equal -28, because the absolute value of 28 would equal 28, the absolute value of -28 would equal 28. So again, we're going to solve it. So we're going to get 4x equals 16, so x equals 4. So here we're going to get 4x equals -40, which means x equals -10. And so those are the 2 solutions that we would get for example 2. There is a possibility that we could get something called an extraneous solution, and then that's an apparent solution that must be rejected because it does not satisfy the original equation. So in example 3, we're going to check for some extraneous solutions. So once again, we know that this is an absolute value equation, so we're going to set it up, and we're going to say that 4x plus 10 equals 6x, or 4x plus 10 equals -6x. And again, we're just going to solve it. So I'm going to bring this over. We're going to get 10 equals 2x, x equals 5. And this one, we're going to get 10 equals -10x, so x equals -1. So those are our 2 solutions. But we must check them to make sure that they both work. So let's do that. Let's put the 5 in. We put 5 in up here. That's 20 plus 10 is 30. The absolute value of 30 is 30. So left side's 30. 6 times 5 is 30. That one works, because we get 30 equals 30. Now we're going to do the same thing with a -1. So that's going to give us -4 plus 10, which is 6. Absolute value of 6 is 6. Put in -1 on the right side, and we're going to get -6. Notice that does not work. 6 does not equal -6, so this is not a solution. The only solution to this problem is x equals 5. So let's jump down to the guided practice. There are 6 of them here to do. Go ahead and do a couple of those. I'll do all of them, and then you can hit pause when you're ready to go. Hit play. And there are the answers for the guided practice questions. Again, notice we have to make 2 equations for all of them. Once we get down to question 5, we had an extraneous one. -1 does not work, so that is an extraneous solution. And I want everyone to pay attention to number 6. When you had 2 numbers on the right side and we switched that, here we had this negative sign. You have to do the distributive property on that. So it's going to be -2x minus 9. So now we're going to jump down to the absolute value inequalities. And these are the same type of thing, only now we're looking at the inequality symbols. Okay, so if you see this less than sign, that's going to be an and statement. So a less than or equal to, those are and statements. Because the distance has to be in between there, and less than this far away and less than this far away, so it's got to be in between. When we look at the greater than problems, those are or problems. So you're going to set those up according to what they are. So remember, if it's less than or equal to or less than, it's an and problem. If it's greater than or equal to or greater than, it is an or problem. So if we look at example 4, we see a greater than or equal to sign. That means this is an or problem. So I'm going to set it up as so. So I'm going to say 3x minus 7 is greater than or equal to 5, or I know that 3x minus 7 is, now we're going to set this up, it's going to be less than or equal to negative 5. We're going to flip the inequality sign and take the opposite of that number. Because we know that it has to be either further away than 5 or further away than negative 5. So now we solve these. So 3x is going to be greater than or equal to 12, so x is greater than or equal to 5. Here we're going to get 3x is less than or equal to 2, which means x has to be less than or equal to 2/3. Okay, so when we look at, did the division wrong, that should be a 4. When we look at graphing these now, because that's what it wants us to do, they should go away from each other because it's an or statement. So we have 0, 1, 2, 3, 4, 5. X is greater than 4. It's going to go that way. And it's equal to, so we fill it in. X is less than or equal to 2/3. Well, here's 1, so 2/3 is right about there. And we fill it in. And so our solutions, once again, have to go outside. So now we'll jump down to the guided practice questions. And again, these are, if you look at greater than or equal to, greater than or equal to, these are all or problems. So do a couple of those. Go ahead and pause the video and you can hit play when you're ready to move on. And there are the guided practice problems 7, 8, and 9. The next thing we're going to talk about are word problems. And in this word problem, we're going to look at now the and problem. And this is a food manufacturer specifies that every family-sized box of cereal should have a net weight of 25 ounces with a tolerance of 1.2 ounces. So that's telling us it can be off up to 1.2 ounces. We want to write and solve an absolute value inequality that describes the acceptable net weight of the cereal in a family-sized box. So as we look at this, we want to be able to figure out what that is. So we know that we're going to call the weight W. And we're going to go, we know that it's 25 ounces. So W minus 25. And then it's going to have a tolerance, which means it can be off up to 1.2 ounces. So it's got to be less than or equal to 1.2 ounces. So notice, the 25 is basically our starting value. 1.2 tells us how far it can be off. Now, here it says write and solve an absolute value inequality. So here is our absolute value inequality. There it is. We did it. Okay, we wrote it. Now we have to solve it. So when we do this, it's going to be W minus 25 is less than or equal to 1.2, just like we did before. Now, since this is a compound inequality and it's an and problem, we want to write it like an and problem. So now it can be off as much as negative 1.2. So we put the negative on the other side. Now this is an and problem. We knew it's a less than or equal to, which makes it an and problem. And so now we solve. Add the 25 to all three sides. So 25 minus 1.2 is 23.8. And there's 26.2. So there is our inequality solved. Now obviously you could have done that one in your head because you knew it had to be 1.2 ounces less or 1.2 ounces more. But that is how we set this up and solve this compound inequality. Now if they asked you what that meant, you would have to explain that, and again in a complete sentence. So you would say that the box of cereal would have either as few as 23.8 ounces or as many as 26.2 ounces. All boxes of cereal would have somewhere in that range. So let's jump down to question 6. It says write a range as an absolute value inequality. Say, all right, you have found that your new winter coat is comfortable to wear when the outdoor temperature is between 10 degrees Fahrenheit and 42 degrees Fahrenheit inclusive. Inclusive means in between. So anywhere in between there. So what we're going to do is simply write this. Okay, there's our compound inequality. I know that if it's below 10 degrees, I'm going to be cold if I wear this jacket. And if it's 70 degrees, I'm going to be really hot if I wear this jacket. So here's our compound inequality. What our goal is to do is write an absolute value inequality for the temperature range, where T represents the temperature in degrees Fahrenheit. So what we're going to do is we want to set it up in that same way that we looked at example 5. We want to have the original value, or the middle value is our 25. That's what we would expect. And then how much it differences, or how much the difference is the 1.2 ounces. So if we look at these two, essentially we want to find what is the average of 10 to 42. I want to find halfway in between. So 10 and 42, we want to find the middle of those. So if we find the average, it's going to be 26. We know that it's inclusive. It has to be in there somewhere. So now we look, how far is 26 from 10? And we know that that is going to be 16 units. Well, we also know that 42 is 16 units from 26. So here is our absolute value inequality. So remember, this is our middle, or what we would expect to have. And this is how far we go from the top to the middle, or how much can we be off. So what I would like you to do right now is go ahead and do the guided practice questions 10, 11, and 12. When you have those answers, you can go ahead, actually, and 13 as well. So go ahead and do those 4 questions. When you are finished, you can go ahead and hit play. So go ahead and pause video and then hit play when you're ready to continue. And here are the answers to your guided practice problems 10, 11, 12, and 13. Notice 10, 11, and 12, now we're talking about the and problems. They're all less than or equal to, so we write them as a compound and problem, and we solve them from there. And we have the graphs. So there's your homework assignment for section 1.7. I would also recommend doing the quiz problems on page 58. Those problems are a review of questions from the last two sections, sections 1.6 and 1.7. So section 1.7, once again, was on solving absolute value equations and inequalities. Then we also looked at what it means to have an absolute value. Again, the absolute value is a distance, so it's going to be a positive. So we're writing two equations or a compound inequality, and then solving those inequalities or equations just like we have in the past.